when you connect a capacitor across an alternating EMF. Before that, suppose if you apply a potential difference of V across the capacitor C, we know that charge on the capacitor Q is equal to CV. Suppose if you apply an EMF E here, then charge on the capacitor will be CE. Suppose instead of a constant EMF, suppose if you apply connect a capacitor across an alternating EMF, which is given by E equal to E naught sine omega t. In that case, the charge on the capacitor plate keeps on changing because the EMF E is a function of time. So when the EMF changes, charge also changes. We know that is why we call this charge a small q. That means it is changing with respect to time. Q is equal to C into potential difference applied is E. Because this is changing, this is also changing. So I, the current is equal to dq divided by dt. That means d by dt of C into E, where E is E naught sine omega t. So E naught sine omega t. So I equal to C E naught is constant. So d by dt of sine omega t. So C E naught into d by dt of sine omega t is cos omega t into d by sine at is a cos at. So sin omega t is omega cos omega t. So it is C omega E naught into cos omega t. Since it is positive, it's in the first quadrant when you write it in sign. I'll write it here. So I is equal to E naught by R. So usually EMF by whatever coming in the denominator is the resistance. So current is equal to voltage by resistance. So this is in the numerator. I'll try to write this as 1 by C omega, because when you put 1 by C omega, that goes up, so it is C omega E naught. So cos omega t, I'm going to write it as sine of omega t plus pi by 2, because sine is positive. So here E naught by this particular value is called the resistance offered by the capacitor. So we call this I naught, or I is equal to E naught by resistance offered by the capacitor. Let me call this XC, where XC stands for 1 by C omega. So into sine of omega t plus pi by 2. So here the maximum value of I is when this whole thing becomes 1. When this whole thing becomes 1, E naught by XC. Let us call it I naught. So here I equal to I naught sine omega t plus pi by 2. Here I naught is E naught by XC. So the current, maximum current in the only capacitor circuit is E naught by XC, where E naught by XC is 1 by C omega, which is equal to C omega into E naught. This is the maximum current in the only capacitor circuit. So here, suppose let us take this thing in the x-axis. Let us first draw time, and y-axis you take EMF. When you take EMF, how the EMF changes? See, E equal to E naught sine omega t. So the EMF will change like this. So this one is E naught, this one is minus E naught, and how the current is going to change. But I is equal to I naught sine omega t plus pi by 2. So the applied one is E naught sine omega t. So the current we got is sine omega t plus pi by 2. Plus pi by 2 means current is ahead by 90 degree. So in only capacitor circuit, current leads or ahead of the voltage by 90 degree. So current leads by 90 degree or pi by 2 radian. Pi by 2 radian or 90 degree. So the current will be because it is 90 degree, it's a cosine function. So when this is 0, this is already maximum. When this is maximum, that time it will come to this 0, 90 degree ahead. When this is 0, it will reach my negative maximum. When this is negative maximum, this becomes 0. When this is 0, it again reaches positive maximum. So the current is drawn like this. So it's a cos wave. So the current is 90 degree ahead, because by the time it is 0, it is already having its positive maximum. That means the wave had started here, something like that. So you don't need to draw this and show, but 90 degree ahead of pi by 2 radians ahead it started. So it is the AC circuit containing only capacitor. So if you draw the phasor diagram, it will be like this. If you draw applied EMF in this direction, then instantaneous current will be 90 degree ahead. So I will draw this in red color. So the current will be 90 degree ahead. Suppose if you draw some randomly this way, if you draw applied EMF here, which is E, the current should be exactly 90 degree ahead here I. So this angle is 90 degree because it is measured in anti-clockwise. So EMF here means current here 90 degree. If EMF here means current here 90 degree. This E and this I are instantaneous EMF, instantaneous current. Because the current is not constant here, it is changing. That's why it is like this.